we're back, continuing to talk about property tables. We mentioned last time that uh, just kind of finished up with this idea that there are all kinds of property tables in your thermodynamics text, and they're describing some pretty complex phenomena that we need to be able to quantify in order to quantify the first or solve the first and second laws of thermodynamics. Now, if we go on a brief tour of the property tables here, let's stop share. And so I'm not going to zoom. I'm not going to, my document camera here is pretty good, but it doesn't zoom in and out real easily. It's mechanical. And so anyway, I'm just going to kind of show you here. I don't have a nice document camera that I can zoom in and out real easily. Um, there are multiple tables, right? And I see you got a glare there. I apologize. We don't have to read these tables right now. It's just showing you that they're in here. This is the Chengle and Bowles most recent edition. This is the 10th edition. Page about 839 is where these start, and they go on for multiple pages. And these are the SI unit version of the tables. So you've seen here, I've got table A1 and 2. I've just shown you. Table A2 goes on for about 3 pages. This is the second page. This is A2B, and then there's A2C. And we are going to talk about, here a little bit later, we're going to talk about ideal gases and what we can do with those. And so those property tables that we just looked at there will come in handy a little bit later in the semester, starting about chapter 4. We'll start playing with those some. Occasionally, we might use this table A3. A3 goes on for a couple of pages. There's A3A is properties for liquids. A3B is properties for solids, some metals and other non-metals. And then down here is properties of food. So if you need to know the specific heat content of things like lettuce or oranges or beef, you've got an estimate in there. Okay. And then where we're really going to spend a lot of time for the next couple of class periods is going to be saturated tables for water and refrigerant 134A, R134 is what we're going to call it. But this is saturated water temperature, I'm sorry, saturated water tables where you have nice round values of temperature and the corresponding saturated pressure values. So basically then what you have in here are properties that describe the dome region. This is the left-hand side of the dome curve and the right-hand side of the dome curve at different temperatures and corresponding constant pressures. And that table goes on for at least a couple pages, right? So nice round values of temperature here. And then you have table A5. Table A5, again, saturated water. But notice now on this table, you've got nice round values of pressure and the corresponding saturated or boiling temperature. And then again, you've got properties here for saturated liquid and saturated vapor side of the dome. And then there are other properties over here. Internal energy, those are the U's. Enthalpy is an H, we'll talk about in a little bit. And entropy for the second law, the S value. And you'll see a similar set of corresponding values, saturated liquid and saturated vapor values. So table A5 goes on for a couple of pages. So table A4 and A5 are actually the same information. It's just on A4, you've got nice round values of temperature. A5, you've got nice round values of pressure. Table A6 then is superheated water vapor. All right, so superheated vapor, which we said is that's beyond saturated vapor. We continue to add energy, and that goes on for a couple of pages. And it's broken up into pressure blocks. Here's 1 megapascal, 1.2 megs, on down, and there's a corresponding temperature row. So given a pressure and a temperature, you can go look up the other properties of specific volume, internal energy, enthalpy, and entropy. Now, when we need to read numbers off these values in a book like this, I will focus this a little bit better. So you can see the superheated water tables go on. Table A6 goes on for several pages. And then you get table A7. That is what you can use for compressed liquid. We'll talk a little bit about that. The last thing we'll talk about in this set of lectures. And then finally, table A8. I will not intentionally give you a situation where you're going to have to deal with ice, or at least the ice vapor transition. You have it if you need it, but that's not something I'm going to intentionally work on. We've got plenty to worry about with just vapors and liquids. Then you have a graphical representation, what we call the Moeller diagram. Right? The Moeller diagram. Moeller, anyway. So, and then also a TS diagram. So these are those tables then in a graphical format. You are welcome to learn how to use these. I could probably muddle through it. I never use these. I'm going to use the tables that I've just shown you on the previous pages, but there is a graphical form. The book is very careful to tell you don't mix, don't use tables for one value and then the graph for another because their scale is slightly different. It's not perfectly the same. And then you've got tables here for, notice this is saturated refrigerant R134A. What is that? We don't really care what it is. We can go look it up. I'll show you what it is. It's listed in table A1. The chemical formula for this, it's a chlorofluorocarbon. Mhm. Um, at any rate, you can see here for table A11, you've got the saturated R134 values for nice round values of temperatures. Just like we saw in table A4, at different temperatures, you can go look up the values on the saturated liquid curve and the values on the saturated vapor curve and the corresponding pressure, as well as corresponding then UH and S values. That goes on a few rows then on this next page. And then one page then of the same thing, but with nice round values of pressure. So A12 and A11 are both describing saturated R134 properties. So you've got values again for the saturated liquid curve, values for the saturated vapor curve. And we're going to like actually put numbers to these and see mechanically how these work. But I just did want to kind of go through a quick tour of the tables. Notice here A13, that is superheated R134 values. I know I've got a glare from this light in here. I apologize. But mechanically, you see that works the same way. We've got rows of temperature, blocks of constant pressure, describing corresponding V, U, H, and S values for different pressure temperature combinations. So that's it when we're in the superheated region. There is a diagram of that, but a couple of pages of the superheated tables for R134. There are no liquid tables for R134. We don't need them. We'll talk about why as we progress through. So again, Moeller diagram for R134A also. Okay. And then some later tables that we'll talk about later on in the semester, mostly dealing with ideal gases. I have a tab in here that it's actually broken off. You can see this yellow sheet of paper there. That tells me that's where my English units start. So there's a set of tables then, corresponding tables, all the ones we just saw for English units. And so if we go look at table A4 in here, table A4, here we've got temperature Fahrenheit, where the other was in Celsius, pressure in PSIA, where the other were in kilopascals. So same exact type of tables, just with English units. So if you've been trying to avoid English units to this point and convert everything to metric, that's normally a dead giveaway if you're using AI or Chegg or something like that. You're going to have to learn how to use the English system. I don't know what to tell you. Um, that's welcome to being in engineering school. Okay? All right, so that's kind of a brief, quick rundown of the property tables, how they work. Again, the equations needed to actually try to estimate a U or an S value can get complex, and it's also, you have to guess, okay, well, should I use this equation for this pressure temperature combination, this equation for that pressure temperature combination, and all that work has been done for us. It was always kind of a massive challenge 50, 60 years ago trying to teach students thermodynamics until we have these nice property tables that we have today that are very reliable and give us good quantifiable values to try to solve first and second law equations. So we have an advantage, and that's what we use at this time. Okay, now where am I at in time? All right, that's a good place to stop a video, and that's what I'm going to do. This video will be a little bit shorter than the others, but that's okay. It's kind of basically this will finish out the previous lecture, and then we'll start the next lecture where we actually talk about, now that we've seen the property tables, let's talk about how do we use those property tables. So that's coming out in the next video.